So hello, I think we have just started the broadcast. So let's give it one last check if everything is okay. Radek?
Okay, I can see your presentation first slide. Yes.
Great. I have just
and your nice face.
Yeah,
in the
great.
camera,
Thank you.
so.
Yeah, it's perfect. Yeah. Hi. And I have just find out that the key L gives me this nice pointer of red color, so I can point to everything in the presentation. So anyway, I think it's almost time. People are still coming, so actually I see the number and it's still increasing. And so what do we do? Do we wait? Or do we start? Radek?
I think it's time to start slowly.
Start. So then we start. Okay, so it's 3 p.m. here at Prague, in Prague, Czech Republic, and let's start the webinar. Okay, I need to close this GoToWebinar window somehow. It should go. Yeah. Okay. So anyway, I'll start it. So let's start. And this will be cut away, right? I hope so. Okay. Okay. So let's start. So hello everyone. This is Luboš Pirkl from CFD Support, and I would like to welcome you to the webinar number 66, where we would like to introduce the new TCAE version. It's version 23.03, and we believe that it's a great version again, because once again we have spent enormous time and effort with developing this to really lift this everything to this level, and we believe it's great, and in this webinar we would like to show you. So a couple of technical information in the beginning. So the webinar is being recorded. So the recording, yes, it will be available on our YouTube channel. So you do not need to follow everything in actually, I hope you will, but the recording will be available. And the recording, then the Q&A, of course. So there will be a Q&A session at the end of the webinar where you can ask your questions, because I guess there are a lot of our current users at the moment in the audience. So I guess there will be a lot of questions. So feel free to ask your questions. We will do our best to answer all the relevant questions during the webinar. And all the questions will be answered actually. So the most representative questions will be answered right away in the webinar. The rest will be answered later via email, but you can be sure that all the answers, all the questions will be answered. And the last thing, together with me is, he's sitting next door, is my colleague Radek Máca. Hello, Radek.
Hello, Luboš, and hello to the audience. Hello.
So what's up? I guess you were looking forward to this.
Yes, definitely. In this magical date, right? To introduce our magical product. So great opportunity for that.
Yes, indeed. Yes. So okay. So thank you. I hope again the last check. I hope everything is working and we can start the webinar. So. Yep. Okay, so let's start. Okay, so I'll start with the general information, like 10 minutes or so, and then Radek will show more particular details of what's on the table, and then there will be the Q&A session where you can everyone can ask the questions. There's a special menu window where you can ask your questions. So please do, and use your time to the fullest, and we will do our best to answer. Okay, so Radek, I think we could switch the camera off and not. Yeah, okay, sure. Yeah. So, hello everyone. Let's get back later. Yep. So it's this icon, and I guess I can continue. So okay. So CFD Support is the company name, and I guess you know, but still, here at CFD Support we deal primarily with CFD, FEA, and FSI, with optimization and acoustics. Those are virtual simulations, and we develop special software for it. So our main focus, I would say our flagship product, is software called TCAE, which is in fact a comprehensive simulation environment where the users can set up the simulation, run it evaluate it, and much more, which I guess we will show a little bit, and anyone can try and make sure. So yeah, technically we can say that TCAE is a set of software modules which are relatively independent on each other, but of course they work best when they work together. But it's a set of software modules for, let's say, geometry creation, for the mesh creation, for the CFD, for FEA, for the acoustics, and for optimization, and all of that can be run in a loop, or just individual modules can be run. So we can discuss this more in detail a little bit later in the presentation. We could say that there are a couple of principles we follow to that, I would say. So we follow a couple of principles. So first of all, it's flexibility. So TCAE is flexible. So it means it's always up to the user the way how it's gonna be used. So some users, for example, use just TCFD module to replace CFD solver in existing workflow, or other users use a large complex workflow where most of the modules or even all of the modules are used. And so it can be relatively complex, or it can be very simple. So it's a puzzle game, and as a result, every user can decide and set up his own workflow, which he likes, which corresponds to his resources, experience, and goals, of course, and etc. So TCAE is definitely ready to be used together with other commercial codes, or with the in-house codes, or with other open source pieces. So it's definitely ready to fit in an existing workflow, or you can create a new workflow if you like. Another important principle for us is that TCAE is unlimited. It's unlimited in terms of pretty everything. So it's unlimited in terms of number of its users. It's unlimited in number of the job scores, sessions, hardware installations. So the users can use their resources to the fullest. That's very important, and it's one of our big, I would say, benefits. It's definitely focused, so that it means TCAE is focused on specific applications, especially on turbo machinery applications and external aerodynamics. So it's been created for them, and it works there best. It shows great performance on these applications, and we can say that TCAE is not a general purpose code. It's a focused code on specific applications, and it's very effective on those applications. You can imagine it's a Formula One, which is not definitely being built to ride on mountains, but on the race circuit, it's the best of what you can have. So you can view it with this optics if you like. And yeah, so we are focused on accuracy at CFD Support, of course. So we believe that every project is based. I mean, the results or the quality of the results are depending on the skills, experience, patience, and dedication, and not quick actions in a rush. And that's the way of our thinking. So TCAE is definitely accurate. And it can be automated to the highest level. So it can be extremely automated and used as a black box, or it can be used as a total high-end software where all the options are open. So that's always up to the user. So the user always decides how deep to dive, how deep to go to the rabbit hole, to how many decisions has to be taken. So we're definitely ready to help with all of these. So that's another important principle, how we think. in the past, we did a couple of, I would say, a lot of benchmarks. Some of them are publicly presentable. Those are real benchmarks, real machines that really exist, and that we are allowed to show them. So all of them are real projects that happened in the past, and what's important, they are anytime repeatable, and we are used to prove and prove and prove again and again. It works, it makes sense, and the performance is here. Another important principle is that our users can use their resources to the fullest. That means TCAE can be run on, it can be actually run everywhere. So it can be run on laptops, or on a PC, on a desktop, on a cluster, or in a cloud. No matter if you are working from home or from your work, of course, in Linux operating system, or Windows or Linux operating system, the workflow is the same everywhere. The TCAE has been developed in a client-server mode. It means so you can stay on the client side on your computer you are sitting at, and remotely compute on let's say a remote resource. So it's really useful, and together with the feature, the licenses are unlimited, because there are no limitations on them. So it's very powerful in these terms. Another important thing is that TCAE is based on open source. So we started it, and it's completely based on open source. So there are more than 60 open source projects in it. And the source code, by the way, developed based on open source, is again open source, and it's shared together with the project. So it's definitely very flexible, and experienced users can change the source code if they like. And on top of that open source, here at CFD Support, we have spent more than 40 many years in a team-focused development to add the graphical interface, to add the automation layer, which makes it effective tool, which is so effective, I would say. Okay, so here is the new version 23.03, which is released today, and it's a little, I would say it's a big day here at CFD Support, because another cycle has been closed, and now it's ready to be shown publicly, and we will be happy for your feedback and for your experience. So there are a couple of things we would like to share with you today, and the most important is your feedback later. So let's take a look what's new. So maybe you noticed that the TCAE turned dark. So now it's dark theme and dark skin, and we want to keep it for the future. So we already got used here at CFD Support, and we believe you will get used quickly too. We believe it's better for corporate identity. We believe it's better for health, and also for the environment to stay dark. So we hope you will like it. And about the release itself, I have just a general information that I could say that we this March, because it's settled that we release new TCAE 2 times a year, typically in March and in October. And what's settled quite well, and we like it this way. In October we make more, I would say like shifting release with big news and big announcements, and the March release is more about getting better user experience and getting things settled and stable. So this is the March one. So the focus is definitely more on the user experience side. So for your information, we have resolved more than 100 issues in our system, in the development system. We have updated a lot of third-party packages. There are a lot of them. So there are new versions of all those, MPIs and supporting third-party software pieces. There's the new dark skin, and we can also say that we did a lot of rather smaller changes to increase the user friendliness. So, and on top of that, we have added OpenVSP to the package. So it's a geometry builder, which is extremely useful, and you can run optimization loops with it, especially for axial machines. It's very effective. So let's see later in the webinar. We made an extensive support for client-server remote computing, and this is definitely not it. We are continuing in it, and you can expect even bigger news in the future, in the next release. We did not finish everything for this one. We have added, for example, some kind of, to name a couple of physical features. There's the polynomial heat capacity option, if you like. The sound reconstruction, or TFEA is now enabled to simulate periodic cases to correspond to CFD, of course. Also, there is the multi-region support for TFEA. There is enhanced report for TFEA, and binary STLs are supported everywhere across the project. And I would say there are new tutorials and even more capabilities. What's very important, we have launched a new CAE forum. It's a discussion forum where we provide free technical support for like mind-like people and open source minded people. So, and we also, the intention is to provide the technical support for TCAE there. So be okay, help yourself and visit the website, and what can be shared publicly we would like to share on this forum, and all the discussions and ideas and recommendations can be shared there. Of course, the private technical support is shared as usual via support@cfdsupport.com. But what can be shared publicly, especially new ideas and new, let's say, resources to inspire all the community, we would like to share there. And over the time, we would like to send everyone there, especially those who ask us about OpenFOAM support. So all the OpenFOAM agenda must be shared and will be answered exclusively via CAE forum. We don't provide OpenFOAM support anymore because it leads nowhere, I would say. So everyone is will be asked to go to caeforum.online, and there we will do our best to support you, and we believe that others will do too. Okay, so it's this release, and the details will follow in the Radex contribution. I will only mention that the next release will be in September, October this year. So we are already working in new capabilities and features, and you can look forward for, again, big news, and you can expect only the best. So in the next version, there will be likely the first version of the new software module, which is called T-Base. We are currently developing it, and it's a really big thing, because we believe that in the future, all the results coming from, especially from CFD, but also from experiments, from measurements, from the knowledge base, should be stored somewhere, and there will be, let's say, there will be large databases where we can use special machine learning algorithms to help us to do better designs very quickly. And we are sure that this is the way. We have already some working examples. It's really great. It's the future, and we believe that in the future we will be a little bit less simulating and a little bit more mining the data and taking lessons from the data and from the previous simulations, because we believe that in the past all the I would say so much important data has been thrown away, and in this optics in 2023 it would be a mistake. We have to save data and take the lesson in the future. So that's what we are working on at the moment, and there will be another a lot of new things still under the development. So let's see. And I guess this would be it from this part, from the general part. And I will ask my colleague Radek. Hello, are you still with us?
Yes, I am. Yes, I am. So feel free to
Absolutely, yes.
send me the presentation.
Yeah. It's waiting for me. Yes, as usual. Yeah. Okay. Yeah. And
so I'm clicking, and
we can see your screen. Yes.
Great.
Please.
Okay. Great. So thank you, Luboš, for the first part of this webinar. And in the second part, I will show you some picked issues which are mainly or which are significant to see for the user. So among the other more than 100 issues resolved, which are a little bit hidden, yeah, and resolved or improved the working user experience or resolve some bugs hidden in the code. So I picked some of them to present, which is clearly seen in the GUI and in the applicability for the cases. So as Luboš already presented, here are the new features I would like to talk about. So it is the dark theme, just to show live how it looks and how it behaves. Just to mention and emphasize that we are still heavily working on the support for Clientserver. So I just would like to mention this feature to be known for the usage. Then there is a new physics polynomial heat capacity setup. The OpenVSP package binaries is directly in the TCAE package, and you can use it for the optimization loops. And one example, new example and new case is the propeller optimization, the drone propeller with the OpenVSP. Then there are many new things and features in the finite element analysis. So from now on, the users can simulate the periodic segments. So the periodic or the solids which are cut off from the full wheel geometry, for example, can be now simulated and connected via periodicities, like in the CFD simulation. There is a report enhancement. So here there are some new automatic visualization, for example, in the report. There is a new multi-region solid, so you can simulate different materials together connected as one big region. Again, very similar like the components in the CFD to keep the workflow easy and straightforward. Then we added a volumetric source mainly for simulating the car park simulation or car park and CO distribution in the car park geometries. So you can put the volumetric source which correspond to your CO input of the running cars in there. And one nice feature that you can play a sound which is reconstructed from your acoustics analysis from your simulation, and mainly find one feature which is not fully visible, but internally all the STLs are treated as binary, which speed up a lot the operation or the manipulation with STL geometry. Yeah, so now, for example, the pre-processing of the geometry, mainly for the large geometry, is much faster than in the previous releases. So let's start one by one. So first one is this dark theme we have introduced. So we played a lot with the colors and visualizations to be modern and nice for the users. So let's say we can directly run it on one of our tutorials. So where we can find the icon, here on the back seat of our test driver in CFD Support.
It's Radek, by the way. It's Radek.
Okay, so I will load one of our tutorials, so you can find it in the installation as usual in the tutorials, and I will take this pipe which is the simpler one, and we can get the results pretty pretty quick. So the layout is very similar, but the colors, all the colors of the graphs and the backgrounds are modified to be really nice for the eye. And okay, I have already loaded, so now I will run it. So all the features are very similar. Only the colors are made to be much brighter and much contrasted with the dark scheme. We have improved the icons, and so you can use it to the fullest as usual. And with the simulation, with the graphs of the residuals, so with the line chart view of the quantities. If I click here, so you can really play nicely with all the evaluations. You can add again more of them, so you can really vary the layout as you want. So this is it. Maybe when the simulation will finish, I will show you the report and the FEA report, the enhancement of it. So there are some new nice features. So this is how it looks from this new version 23.03. So this is a dark theme. So just try it by your own and go through the GUI. Just to mention and just to emphasize that we're really working heavily on the support for client server. There are some issues which need to be solved. How to connect to Linux. Linux system is okay, but now a lot of issues and troubles were resolved to connect from the Windows to the Linux server. So Windows, from the Windows client to the Linux server. The connection is pretty the same. It depends on the topology of connections, but you just need to be able to connect via some given port to your CPU in your local system or on the cloud or whatever. So for the details, you can see the one. I think our previous webinar 65, where we spoken about the client server connection in more detail. So feel free to watch the previous webinar for more information about this. The polynomial heat capacity, pretty direct options which you can find in the TCFD. In the TCFD module in the physics. So heat capacity model, polynomial, so pretty straightforward. So this is set directly to the constant, but you can follow, you can find formulas, the polynomial formula for your particular fluid, and you can choose it for the compressible simulation. So pretty straightforward. Feature. The new, let's say, the new possibility which we found is the OpenVSP, to use the new open source package or additional open source package for creating the parametric models, where we see a lot of very potential, and there are very tools for that, and each of our customers has different thoughts and different goals. So this is how to introduce another topic and another tool for that. So OpenVSP binaries is now delivered within the TCAE. So if you have a model ready, you don't need to install it within the within the TCAE, because TCAE knows where the binaries are found. So you can use it directly, and we prepared a new tutorial, so you can directly try. If you would like to use it within the GUI and how to study the tool in general, you can go to the openvsp.org page and you can download it, and you can find a lot of tutorials and so on. So this tool was originally developed as a parametric geometry tool for aircraft and propeller designs, and it was developed by the NASA and released under the open source agreement. So you can use it as you want. So maybe let's let's quickly show. So if you install the GUI, they are available both for Linux and Windows. So if you open it, it has a simple editor. So for example, I will load the tutorial propeller. So if I go to the installation, one up, and to the tutorials, into the TCFD TOpt, and here you find the propeller optimization, and in the geometry builder you will find the propeller which is parameterized. So we parameterize a DJI propeller for the standard drone, and so if I load it here, you can see the rendering of it. So now I need to focus. Maybe I can change the center point. Let's see how it looks. So this is the DJI propeller in the default, and here in this package, I'm not very expert on it, but you can find a lot of parameters to be set, like the chord and like the thicknesses and so on. So for example, if I go to the blade and I go to the, for example, twist section, so you can set the twist section as a function of the radial coordinate. So if you then move with the point, or you can set the section to be adjusted, then you will see how the blade is changing permanently. And all these parameters you can export and use it as a optimization loop. For example, the chord length, so I can emphasize the length in this area. So there are really, this is ugly, but but as an example, it's perfect. So you can really play a lot with all the kinds of shapes and propellers and even NACA and other profiles. So it's very, very, very nice tool for the parametric models. And as the example, we have this proper optimization case. So maybe I can again find it and load it. So I will open new TCAE window. I can load this tutorial. So again, this tutorial you can find within the installation. TOpt proper optimization. Here in the geometry builder folder, there are the sources for the OpenVSP, and the proper optimization is the TCAE case itself. So we can load it. Again, the simulation setup is very the same. So first you prepare the mesh and the TCFD setup for a default geometry, and then you can employ the TOpt. So let's say, just to see how. So this is the big, let's say, big domain, which in its center the propeller is placed as the rotating region, and the TOpt basically just standard optimization where the direct method or algorithm is run up to the, say, 150 runs in maximum. And as optimization parameters, there are picked 4 of them, 2 twists, some general beta, which is the angle of attack, the overall angle of attack, and the thickness of the blade at some position. So again, you can add more of them, all which OpenVSP provides, and as the results, which you can find on the YouTube channel, our YouTube channel. So okay, I don't want to see that. Okay, this is already open here. So this is the visualization of the TOpt running process. So you can see each run with the evaluated torque, lift, and optimization function. And basically, this is how the TOpt loop evolves, and at the end it finds the optimum design with respect to the minimizing or maximizing the optimization function. So this is really nice tool, because you can parameterize wide range of the propellers, even impellers. For axial fans, for example, it's very straightforward, and you can find your best design for your application, and it's pretty straightforward forward, and all tools to achieve that are available. Yeah, so you can play with that. It's part of the installation. So what we have next, so let's go back to the presentation. Yeah, now several features which were added to the TFEA module. So first one is the periodic segment, which was not available. So you can imagine that you have some kind of axial fan and the cut, which includes also the hub. So in the previous version, there was no function or no option how to connect the periodicities, for example, here in the solid. So now automatically they are just, so the workflow is almost the same. There is just one new option to apply a periodic boundary condition. You will just set how many periodic segments build a full wheel, and the rest is very the same. And at the end, you automatically get the results for the virtual full wheel geometry with all the displacements, all the von Mises stresses and frequency analysis. So everything is there. And maybe, okay, I will wait for that. So this is directly available in the report. Even these visualizations are there. So this is a new feature. I think I have a slide for that. The next option or next feature is the multi-region solid. So you can now create your simulation domain, which is made from several components. So this, let's say, workflow is split into two parts. First part is to create the mesh for the FEA. So it's very similar to the CFD part. So you can define as many components as you want. For each component, you need to have one solid, waterproofed or closed solid, which defines the region. So you define the mesh separately for each region. And then in the TFEA setup, in the materials section, you can set 2 or 3 or more materials and assign the components with the given material. So for example, if we have 2 concrete region and 1 polystyrene region, and then in the component connection, you just define couples which are connected, and internally it automatically find the connections, and basically that's all. So it's really, again, pretty straightforward and easy to use. So, and definitely you can combine even with periodic segments and multi-region solid. And when you would like to see the results, so you don't need to, for the first visualization, you don't need to do it manually. The TFE report automatically visualize all, for not all of them, but for example, for Mises stresses, displacement, and the displacement for each eigenmode for the given frequency, which we get from the frequency analysis. So maybe I can go for our pipe just to check if we have this HTML report. Okay, I close it so I can open it. Here I can go for report. So this is the report of CFD. And okay, I can switch here to the FEA report. So again, standard information, and for example, for the static analysis, we have some overview for the displacement and von Mises stresses, and I think here is not the frequency analysis, but you have it for each point. Maybe if I open, okay, maybe I can open the case where we have this periodic segment example. Where is it here? So load. I think I can find it in our webinar folder, today's webinar, and periodic FSI, yes. So this is the case when we applied the FEA to the periodic segment of an axial fan. You can see, so this is the flow domain, and here we have the solid domain. So FSI FSI applied on the segment periodic case, and if I go to the TFE report, so again, okay, maybe, yeah, so this here we have this displacement and the frequency, yeah, frequency renderings for each eigen mode we asked for. Yeah, so again, you can visualize what you want, real or imaginary parts of it. So that's it. What you can find in the new version and in the report of TFEA. Well, another feature is that we add the volumetric source for passive scalar. So there is a volumetric source which you can add to the passive scalar, and typically if you would like to, for the application of car park ventilation, so usually you have some reports or some limits which CO2 or CO2 concentration at each levels above the floor, for example, and you know about the source from the how many cars go there per hour and so on. So based on this information, you can put the source of CO, carbon monoxide, and you can analyze the region with high, for example, high concentration, just the fans. You can add the jet fans. We are working on the new features, so to add the sources locally, to add jet fans pretty easily. So this is under high development now, and the main features are already available in this version. So you can start playing also with this direction of applications. Well, and I think I'm almost at the end, and one nice feature at the end is the sound reconstruction. So now if you are doing the acoustic analysis, so in the final report you can find the audio tracks which you can play how the sound you can play the sound of the noise you measured at the given observer for the particular application, for example, for axial fans and so on. So if I show you an example of it, I think I have here, yeah, again, here, new release, acoustic report. So this is an example of acoustic report, and here the observer summary for each point, for each observer, you can run the sound, but I think this webinar application can't record the audio. Okay, that's what it is. Yeah. So we can mimic like shh. So this is it. So you can try by your own. You can use the TCAE. We can run TCAE example, which you can find in the tutorials, and try experience the sound by yourself. Yeah. So you can find it in the standard report. All right, and I think maybe I can switch to the full screen because I am at the end of this live example of the main features which are visible for the users. And I think now we can go back to Lubos to conclude and maybe to go directly to the Q&A session. So Lubos, are you there?
Yes, indeed. Yeah. Thank you for the great presentation, Radek. Thank you. I followed carefully. I enjoyed it so much. Yeah, and yeah, we were unlucky to show you the sound reconstruction from the simulation, but anyway, we will make it work for sure. for the future, but it's there. If you on your computer, you can hear it. Just the webinar client does not support it, or we did not find 5 minutes before the webinar how to make it available for you in the webinar. Okay, Radek, I think it's time to move on in the presentation. Now it's of course a Q&A. So I would like to ask the audience to ask your questions about anything. It's your time, so ask your questions. We will do our best to answer it. And as mentioned before, we will perhaps pick those representatives we think other users might be interested in, and the rest will be answered via email. So we'll answer everything. So can ask. And at the moment, I have to say, I'm a little bit surprised. I don't see any representative questions to answer publicly. So Radek, can you see one?
Okay.
Or do you have one? What we can answer?
All right. What?
Yeah. Well. Okay. Okay. So we are a little bit unprepared, and okay, Tim has a question. I can see the question mark. So let's look at it. Tim, yeah, our friend from Canada. Hello, Tim. The newer license will work with older versions. No, the licenses are always hard coded for the particular version. So the license I sent you yesterday works only for the 23.3, and that's how it works. That's the system. And by the way, we will perhaps we will change it in the future, because the current system of licensing is not fitting what we want to use. So it needs some changes, but I don't know when. Perhaps later this year or maybe next year we will change the system, because it's crazy. But for sure it will remain that it will be completely unlimited for the particular user. I mean the organization can use it in an unlimited way. Yeah. Yeah, and Tim is asking, but let's keep it via email. But you can use all the versions you receive. You can use them in an unlimited way, and they will work forever. So there is never a trade-off of anything. So you can use older version and new version, and all of them together. They never compete each other, because they are completely canned and independent on each other. So that's a general enough answer. Yeah, Bistrik, hi Bistrik is asking if the theme, if the skin of the graphic interface can be changed to the light one. Actually, it could be, but okay, we need to try it. We need to try it. There in the beginning there was no intention to allow it, but we know how to allow it. But then I'm not completely convinced how it would look like. So the skin, the intention is to keep the dark skin, but let's see. There is a special configuration QSS file in the installation. If you remove it or change the settings in it, then you'll be able to change the interface. But that's too detailed. So let's discuss. Yeah, Radek.
If I can add, if I think maybe if I understand correctly, so Bistrik asked for the screenshots of the rendering. So it's possible to change the background color for the rendering.
Yeah, of course. Yeah, of course. I'm sorry, I completely missed this.
Remain. It's not possible to change the white skin of the menus and so on. Yeah, so the bright skin. But for all the renderings, you can play with the background color and whatever. So this feature is still available. for the
Yeah, of
screenshots.
course. I was answering the menu and everything.
Yeah, right.
The background can be changed, of course. It's actually very simple, and we can show you if you like. It's very straightforward. And also the report remains the same, and also the PDF version of report remains the same. It's a little bit ugly, but it can be printed. So at least this remains the same. Sofiane, hello, is asking about whether we are planning to add the LES calculations and options. There are already some options, right? There's the DDES, right, and and other options. And on the OpenFOAM level, what's in OpenFOAM, it's pretty straightforward to edit to the graphical interface, but there are some tests around and these, but adding it is not a big deal, and using script to edit is not a big deal at all. So let's discuss this more in detail. But yeah, it's definitely a question. I know what do you mean, and what you are pointing to. Yes, with the new acoustics module, that there is more and more a need of transient simulations and LES especially. Yeah. So let's discuss this in the upcoming benchmark. So this. Yeah. So we have a lot of questions at the moment, so let's pick some of them. So Debasis is asking fire modeling in the car park. The fire itself is not available, but we were quite successful in one particular project here at CFD Support, simulating the car park, and we will use this experience and this knowledge to put it in TCAE. So we're working on it. It's now quite, I would say, usable for car parks, and in the future we will make it even we will add extra options. Yeah. Yes, this is difficult to. Okay, Radek, what do you think? Do we have some I would say relevant questions for the audience to see, or?
Well, there are many of very particulars, maybe to be answered afterwards via email. But we have a very nice comment from Heiko. Hello, Heiko.
Yeah, hi, Heiko. Yes, thank you for long time support. Yes, and yeah, again, Frederick, the typical usual question: will the webinar recording be available? Yes, it will be available, and we will send you the link, and you can view it in your leisure, and of course you can get back anytime, and we will do our best to answer. So all the questions will be answered, I promise. There are a lot of them. Most of them are like very specific and difficult to discuss, and perhaps we don't know answers at the moment. So let's close it here. It was a little bit chaos, but I mean the Q&A, and but let's move. Let's move a little bit forward. We are going for a party tonight, so let's do the rest very quickly. So these are a couple of those who already share our visions with us. So we hope there will be also others. And I think it's time to thank you for your attention. We are definitely looking forward to your feedback on TCAE. It's our job and our pleasure, and also we are very curious about what you think about it, and it's a food for us for the next developments. So Radek, do we? Okay, Well, okay. I may perhaps this is maybe Radek ran away already.
I switched off the microphone.
Okay.
So thank
Okay.
you to everyone. Thank you for your valuable time you spent with us, and see you next time, or discuss additional topics, particularly via email or via so later.
Yes.
Okay.
Thank you, Radek. Okay. Thank you, Radek. Thank you, everyone. And let's keep in touch, and let's get in touch later. So thank you for your time, and bye-bye for now.